Hi, my name is Matthew Diesner, Director of Business Development for Boonton and Noisecom.
The demonstration today is going to highlight how we use Boonton Electronics peak power sensors, the RTP5006, and Noisecom noise sources for over-the-air measurements. Noisecom has been providing noise sources from 700 MHz to 110 GHz, which is ideal for today's evolving 5G and mmWave development of MIMO chipsets. Devices under development today are high-density multiple antennas with combined amplifiers, which make conducted measurements almost physically impossible. Noise sources can be used for calibration of various parts of the over-the-air testing system. We can use the noise sources for path loss of the cables, antenna performance, and calibration of the various measurement equipment such as VNAs, spectrum analyzers, and power meters. In today's demonstration, I have a mmWave which has got a center frequency of 2.5 GHz and at 40 MHz additive white Gaussian noise source, which puts out a crest factor of approximately 10 dB. Inside this device is also a 14 dB amplifier. We're feeding this signal into an RF isolation chamber that contains two Vivaldi antennas. The one antenna is hooked to the output of my mmWave. The other antenna is being hooked up to a spectrum analyzer and a peak power sensor from Boonton Electronics. As we can see on the display of my computer, I have the spectrum analyzer display with an average power, and I also have the Boonton power analyzer giving me average power readings. If you note on the bottom right-hand side of this display of the power meter analyzer, I also have a peak power, and in this case that is my crest factor, or the peak to average power, which then highlights our crest factor capability. What I'm going to do is increase the amplitude into the amplifier in 1 dB steps. What we will see is a correlation between the average power of the power meter and also of the spectrum analyzer reading. What we are noticing though is that as I increase the amplitude, my crest factor now has decreased substantially. So in my complementary cumulative distribution function, I can see at 1 part per million, I have almost a 3 dB decrease in my crest factor. So I want to thank everybody for paying attention during this demonstration. If you would like more information, please go to noisecom.com or boonton.com, where you will find some information regarding this demonstration. We have a 5G mmWave testing brochure, which also highlights how you can use noise sources for noise figure measurement, noise power ratio measurements of amplifiers, and also the over-the-air testing. Thank you very much. Have a good day.